This is a function generator or signal generator. It does what it says. It generates a signal according to our specifications. So right now I'm displaying a sine wave. I can display a square wave on the screen here, ramp, and so on. But I will want to use a sine wave. And I will set this, I have to choose channel 1 or 2. So this is the output for channel 1, output for channel 2. We're going to connect BNC cables to them. And we select between channel 1 and channel 2 by pressing this button. Now, the color we want to look at is in the corner here. If the color is yellow, that corresponds to the output for channel 1. If the color is blue, it corresponds to the output 2 for channel 2. So I'm going to use channel 1, and I'm going to make a signal. Let's say that I want to pick a frequency, so that corresponds to frequency. And this knob will select between period and frequency. So let's go to frequency and say I want 1 kilohertz. So I press 1, and then look at the scale here. 1 kilohertz signal is selected now. Then I'm going to go to the next button down and set the amplitude. So that's going to be the voltage. And let's say that I want to use 5 volts, or how about 5 millivolts peak to peak. So my signal will have 5 millivolts peak to peak and 1 kilohertz frequency. I'm going to output that signal, so I'm using this BNC cable again. I'm going to plug it into here and then push it in and twist it, and I'm going to output it to a DMM. I'm sorry, to the scope, DSO. So I'm going to insert this into channel 1, and I will want to see the signal, see the same signal on the scope. So I will use the vertical gain here and the horizontal gain and see if I can display, oh, there it goes, display a signal. Okay, looks like we have a signal. Now, I will want to move this up and down. Oops, channel 1. Let's move it down so that it starts here. I don't like the fact that it's wobbling so much, so I'm going to hit the run stop button so that my signal is just stationary and I can count divisions more easily. So I have 1, 2.5 divisions roughly. 2.5 divisions times 2 millivolts per division gives me 5 millivolts peak to peak, which is what the signal was given to us by the signal generator. Then we want to do the same thing with the period and frequency. So there are 500 microseconds per division, per horizontal division. I'm going to move my signal left and right so that it's easier for me to count divisions. So 1 period is from here back to there. That's 2 divisions times 500 microseconds, and 1 over that will be frequency. So the frequency will be roughly 1 kilohertz, which is what the function generator was putting out. For the scope, if I don't want to play with volts per division to find the signal, there is also a trick here where you can press the auto button and that will find the signal for you automatically. You don't have to play with the dials, but I think it's more fun to mess around with the dials and find the signal yourselves.